Hi everyone and welcome to this Mo video on quadratic equations. My name is Darren from mathsguru.com. Yup, that little place over here that you can sort of go and download all the lesson notes I'm about to write all over and watch all these videos in order, and there's VCE stuff and exam papers and all sorts of different things over there for you. So please head over there. But before you do, watch the video and hopefully you'll subscribe to my YouTube channel. If you subscribe, it means the world to me, like massive amounts. Very few people watch my videos. By the end of the day, if people will sign up, if my subscriber count goes up by 3, I get really, really stupidly excited. Because ultimately, who wants to watch math videos? So the fact you've done this is great. And if you can, and I know you're not going to, and this feels really stupid, if you can tell your teachers about the fact that this content exists, I'd be greatly appreciative. Yeah, your teachers might know other students who can actually benefit from this as well. And it'd be great if they knew about it. Right, that's the needy stuff over. Let's get on. What am I going to do? Well, pretty much you can pause the video if you want to and have a look over that. But I'm going to sort of recap a lot of the work that we've probably already done in a previous part of this course. And yes, those videos are on Maths Guru and it's absolutely free to sign up. You can head over there, sign up, put in your school email address. Life is good. Right, so we've looked at quadratic equations. And by that, we've had equations maybe like 3x squared plus 2x minus 4. And we've factorized them. We've used the T method, or you've used the cross method, or whatever way you've been doing it, to be able to write it in 2 brackets. Generally speaking, factorizing it, all right? So we've turned 3 of those terms into a set of brackets, which when multiplied out would obviously give you this. So we factorized it. But the point of factorizing is actually really, really helpful. It actually gives us some information. Well, it does if this equation is equal to 0. Right, so we can use something called the null factor law and what have you. And a little bit in a previous sort of video, we looked at the null factor law and what it could mean and etc. So what we're going to look at now is the fact that crossing points through x-axis, being called roots or solutions, becomes really important to us in mathematics, right? Solutions of quadratic equations, massive. This null factor law also really, really important, all right, to find the crossing points. Hold on. So the null factor law helps us find the crossing points, and it has something to do with this equals 0. Okay, and I can't say it more strongly enough that quadratics is used heavily in years 10, 11 and 12 here in Australia and pretty much all over the world. In every course, in every country I've taught in, quadratics is massive, and the skills behind solving them, massive as well. So should we get going? Now, what is a quadratic equation? Well, basically anything that can be written in this format. Now, I'm going to say at the moment the equals 0. You haven't necessarily at this point dealt too much with the equals 0. You've always had this ax squared plus bx plus c business. And you're going to go, huh? What's this a, b, and c business? Well, remember, they can just stand for numbers. So if we go back to what I did before, so if we had 3x squared plus 4x minus 2, for example, and we compared that to ax squared plus bx plus c, then basically you're just looking to compare. And a lot of maths is about comparing. It's looking and going, well, hold on, what's in the same place? So because the a is in front of the x squared here, and the 3 is in front of the x squared there, we would know that the value of a there was equal to 3. If we have a look at the b here, that's the 4 there, so we would say that b was equal to 4. And what would my value of c be? Well, this is a bit of a trick because that is plus c, and that's a minus 2. So in this situation, c would be equal to negative 2. So a, b, and c are just placeholders for numbers. We can have any number of numbers in there. The equal to 0, as I keep saying, and I'll show you what that means in a moment, is basically a very important part of this course because it tells you where the quadratic crosses the x-axis. And again, I'll do some show that in a moment. Right now, again, math is a big fat trick, isn't it? We are here to try and trick you, and we can write equations in all sorts of different ways, right? So all I've done is taken this general format here and I've just moved things around. So basically that's like 3x squared plus 4x equals 2. That's exactly the same equation. I've just written it in a completely different way. Or what about 3x squared equals minus 4x plus 2? Again, written it in a completely different way. I can factorize things out. I can divide things. I could write that as x squared is equal to minus 4x plus 2, all divided by 3, for example. All right, now again, when you look at these things, the trick, and the big trick is to look for the value of the x squared. If that's the highest floating number, it is a quadratic. If I had an x cubed, that's called a cubic, and we're not going to be doing those. So we're looking for this x squared to be in there somewhere. And as we've noticed before in previous videos, we don't always have to have that middle term, do we? In fact, we don't have to have any of these terms. A quadratic is defined by the x squared. And again, we trick you by using different letters. Oh my God, why is math so tricky? Because we're trying to test your understanding. Right, happy with that so far? There we go. So what I've done now is put some values in so that when you download these for your summary notes, you can actually say, well, okay, now I understand what he means. So here I've come up with a different quadratic, 3x squared plus 4x plus 1. It's still of the form ax squared plus bx plus c. What I'm saying here is there's an x squared term with a number, there's an x term with a number, and there's a constant term with a number. Again, the factors equal to 0, come back. But if you want to sit and spend time doing it, each of that equation there can be reorganized or moved around to become these 3 equations there, and more so, all right? So your algebra skills now are massively, massively important. If you can't move things around, add and take things away from either side, you're probably going to find this a little bit more challenging, which isn't to say you can't learn it. Don't get me wrong. Don't give up now and go, oh, he says I can't do it. I'm done. Just realize it's going to take some practice. Right, what does a quadratic graph looks like? Well, basically, here are 2 examples of a quadratic graph. They are effectively a U shape, and I'll come back to that in a moment. Yes, that basically just moves around a set of axes. Now, as it turns out, I have a nice little thing here called Desmos.com. Now, you've got access to all this. You can go to Desmos really, really easily. I'm just going to click a button so it lets me interact with this, and let's see what comes up. So I'm going to now just do x squared on this.